Hey guys, my name is David Mansky. I'm a junior. I've been in math team for 2 years, and my favorite math subject is algebra, and that's a good thing because we'll be doing some algebra today. Alright, our problem is Al's age is the same as Bruce's age and Carl's age together. In 2 years, I will be twice as old as Bruce will be then. 6 years ago, Carl was twice as old as Bruce was then. And how old will Carl be in 2 years? Alright, so we can get three equations from this. First, we can get Al will be the same as Bruce and Charlie. We also know that in 2 years, we'll have Al plus 2. He will be twice the age as Bruce will be in also 2 years. And then we have Charlie in 6 years ago will be the same as twice that of Bruce's age 6 years ago. Alright, now we have our three equations. We can rearrange a couple of them. We're going to isolate the A and the C. So we'll have A equals 2B plus 2. We have C equals 2B minus 6. And we're going to plug those back into the original. So we have 2b plus 2 will be the same as b plus c, which is 2b minus 6. We combine our like terms. We have b equals 8. We know Bruce is 8. Now we need to get Carl's age. So we're going to plug that 8 into Carl's age. So we have Carl equals 2 times 8 minus 6. So we know Carl will be 10. If we add 2 years to that, the original question is how will Carl be in 2 years? We have Carl will be 12.
Hi, my name is Kaylee Wagner. I am a current senior. I'm on the math team, and my favorite kind of math is advanced algebra. So this was the problem I am going to explain. And originally, the first thing I noticed when I looked at it was that all of the base numbers can be written as powers of 2. So obviously, 4 can be written as 2 squared, and then we would multiply that by whatever exponent it is. 2 is just 2. 8 is 2. 8 is 2 cubed, so, and then again, you just multiply that, and then that would equal, again, 2 is just 2, and 4 is 2 squared, and 1/16 is actually 2 to the power of negative 4. So once I did that, I would just go ahead and rewrite all of these so that the numbers that I created by turning 4 into 2 squared and 8 into 2 cubed, just so that they all made sense with this. And all of the fractions actually canceled out, so it's just the number on top, either regular or multiplied by a negative 1. And then because we are multiplying all of these exponents, you can just go ahead, because we are multiplying the base numbers together, you can just go ahead and add all the exponents. So it would, on one side, it would turn out being 2 to the 4k plus 3 equals 2 to the 5k minus 2. And so we know that 2 to the power of 4k plus 3 and 2 to the power of 5k minus 2 is equal. We can just go ahead and write that, so that 4k plus 3 equals 5k minus 2. And then we can go ahead and simplify it out. So 4k plus 5 equals 5k. And then we have k equals 5. And yeah, that's how you would do that problem.
Alrighty. Hello. My name is Molly MacDonald, and I am co-president of Math Team along with Gavin Schilling. And I'm going to go over a problem today. So I found this problem in the Algebra 2 packet, which is the juniors packet from last year. And although it seemed really difficult, it actually had a decently simple solution. So let's get into it. So we have k is equal to root 4 plus root 4 plus root 4, and then it obviously goes on for a while. And we want to put it in the form k is equal to a plus b root c over d. And so we can get the sum of these variables. Okay. So right away, this kind of looks like the quadratic formula, right? We have a number plus another number times the root of a number over a number. So what can we do to get k as a quadratic? Well, we can square it. So we can get k squared is equal to what? 4 plus root 4 plus root 4 plus root 4, and it goes on forever. Well, this is actually k. So what do we have here? We have k squared is equal to 4 plus k. Well, let's get 0 on one side. So we have k squared minus k minus 4 is equal to 0. Well, let's use the quadratic formula then. So we have negative b, so negative negative, so 1 plus or minus the square root of b squared, so negative 1 squared, minus 4a, which is 1, c, which is negative 4, all over 2a. So that's equal to 1 plus or minus the square root of 1 plus 16 all over 2. So right away we know that the minus isn't going to work here, right? Because we have a positive number up here, and using a negative would give us a negative number here. So the real solution is 1 plus the square root of 17 over 2. So we want it in this form. So a is equal to 1, right? B is equal to 1 because the coefficient of root 17 is 1. C is 17. And D is 2. So they're asking for the sum of these values. So 1 plus 17 plus 2 is equal to 21. And that is our answer.
So here we have a geometry problem. My name's Ryan. I'm on the math team. I'm a sophomore. And my favorite type of math is algebra. So we have this geometry problem where we're trying to find k. We're basically just going to use a squared plus b squared equals c squared to find every hypotenuse of these triangles until we can get to here, to this one. So the first one is 7 and 24. So just plug those numbers in. Plus 24 squared equals c squared. Then we get 49 plus 576 equals c squared. 625 equals c squared. Square root of c squared equals square root of 625. C equals 25. So that's our first hypotenuse. Write that in the picture, 25. Then we have 25 and 7. 25 squared plus 7 squared equals c squared. 49 plus 625 equals c squared. 674 plus c squared. 674 equals c squared. C squared. Square root of c squared equals square root of 674. 26. So that's our second hypotenuse, 26. Then our next a and b is 26 and 19. So we have 26 squared plus 19 squared equals c squared. And then that gets us 676 plus 361 equals c squared. And then 1037 equals c squared. And then the square root of c squared equals the square root of 1037. C equals 32.2. 32.2. So now we're going to solve for k with these two sides, 20 and 32.2. 20 squared plus 32.2 squared equals k squared. That gets us 400 plus 1036.84 equals k squared. Then combine those, you get 1436.84 equals k squared. Square root of k squared equals the square root of 1436.84, and then k is 37.91.
Hi, my name is Gavin. I'm a senior and a co-vice president of the math team, and my favorite type of math is statistics. So I'm doing a statistics problem today where Judy is playing doing a psychology experiment. She's going to play game A and then game B. It also tells us that the outcomes of game A and B are independent. It tells us that winning game A has been set to 0.7. The probability of not winning game B, which is the same thing as losing, is equal to 0.4. It tells us that there's no ties, and we have to find the probability that Judy will win at least one of the 2 games. So first, what does 0.7 and 0.4 mean? So in statistics, a probability of 1 is equal to 100%. Probability of 0, 0%. So a probability of 0.7 is 70%. So now we got that out of the way, we can look at this part where it says that they're independent. Independence in scenarios just means that the outcomes of one doesn't affect the outcome of the other. Because game A and B don't affect each other, we can look at them as a separate system, sort of. So in statistics, it also says that in a system that's on its own, the probability of each outcome, of all the outcomes, have to add up to 1 or 100%. So that the total options, probabilities of each option for game A and B, always have to add up to 1. So because there's only 2 options for both games, winning or losing, because there's no ties, we know that losing game A has to be equal to 0.3 in order to add up to 1, and game B, winning it, has to equal to 0.6 to add up to 1. Next, we can look at the system of playing both games. She can win both games, she can win one or the other, or she can lose both games. So in order to find the probability of each option, we're going to multiply the respective probabilities for each game, right? So for winning game A, that's 0.7 from our chart up here. That's winning game B is 0.6. We multiply them because they're consecutive events. We always multiply consecutive events. So the probability of winning both games is 0.42. Fill out the rest of the chart. This tells us the probability for each option of playing both games. And just like A and B, the total probability of each option, they have to add up to 1, which they do. So the question asks us to find the probability of winning at least one of the 2 games. So that is all the options except losing both. That's what that means. So if we add the probabilities of all these except for losing both, that gives us 0.88 or 88%. And that would be our final answer, except it asks us to express our answer as an integer or a common fraction. Integers are like whole numbers, so no decimals or fractions. Since we have a decimal here, you can convert it by hand into a fraction, or I'm going to use a calculator because I'm bad at mental math, and that is 22 over 25.